evidence, because the engineers that I interviewed, some of them were real expert engineers, and they were pulling in salaries 4 or 5 times as much as other engineers of similar standing. And in the end, what is it that distinguished those engineers? They had an implicit understanding of this collaboration business and how to create value for their clients. They had developed that understanding by trial and error and more or less by accident, and many of them couldn't describe it in the terms which I've been able to describe it to you today. But the fact remains that they're there, and the book essentially captures what it is that they do differently. So the opening is there for any engineer to study the material there, learn from it, and you'll be able to do the similar things and make yourself a lot more valuable for your clients and your employers. And in the end, you'll be able to demand more money.
That was James Trevelyan, who's the author of the book, The Making of an Expert Engineer, and an educator down in Perth, Australia. My name is Bassanio Peters, and I'm the host of the Grinding Gears podcast. Making sense of specialized engineering knowledge is not easy. A majority of the technical know-how is actually learned informally on the job and by doing. If you're fortunate enough, you've had an incredible mentor who's shown you the tricks of the trade. If not, don't worry about it, because this podcast will serve as your own personal tribe of mentors. In each episode, we will extract tribal knowledge from top engineering and manufacturing leaders to help you on your journey. There's really no way of knowing what information you're going to need around the next corner of your career. So let Grinding Gears be your guide. In this first episode of the Grinding Gears podcast, we speak to James Trevelyan, who again is the author of the book, The Making of an Expert Engineer, and an educator down in Perth, Australia. I wanted to talk to James to get a better understanding of what he personally feels makes you an expert engineer. He spent countless years researching this particular subject and traveled all around the world and met with large multinational organizations and spoke to their engineering teams. And then in other parts of the world, really had conversations that were eye-opening and enlightening for me. So it's a really casual conversation about this topic. Some of the things that James addresses is, for one, is engineering actually less expensive to do overseas? There's been an influx in offshoring, but James talks about if that's actually the case. In the intro statement, you heard James say, what are the things that really drive commercial value for organizations? What are the things that the top engineers do that allow them to demand more money? So we'll get to the episode here in a second. Want to say thanks for joining us, and thanks to our sponsor, SolidWorks. Hey, James. First, thanks for joining us today. It means a lot. You're actually the first person I've interviewed on this podcast. So again, thank you for being with us. I wanted to get a little into your background and experience, because for me, it's always been fascinating to understand how people get started in the engineering space. Me personally, I kind of stumbled upon this industry over 13 years ago. So can you tell people a little bit more about your background and experience?
So I started in aerospace and defense in Britain and moved back to Australia, and then had this wonderful experience of developing sheep shearing robots for about 20 years, and got into all kinds of things in robotics, machine vision, and of course, dealing with sheep. I actually had to learn how to shear a sheep myself in order to teach the robot.
From aerospace and defense to creating sheep shearing robots, that's diverse experience. And you may think, wow, that's something that I wouldn't really necessarily be interested in if you're a new engineer. Think about the experience, the knowledge that you gained along the way. I think it's super important for people to try and find what their passion is. And sometimes you have to dive into things that you wouldn't necessarily think you'd be interested in. He worked sheep shearing robots for 20 years. 20 years doing that. Do you think that was something he originally intended to do? No. But I guarantee it helped him in his portfolio and especially his knowledge as an engineer.
Having done that, I then decided to move on to academic research and was confronted by a graduate student who said, you built a famous robot. I want to build a famous robot too, but you tell me what the robot should do. And instead, I turned it into a question. I said, look, we're in the mid-1990s. People forecast there would be no one working in factories by now. They would all be displaced by robots, and that clearly hasn't happened. I want you to find out why.
Come with me if you want to live.
James is reminding you that robots haven't completely displaced workers yet. But in the future, with the rise of AI and automation coupled with robotics, there's a greater chance that more jobs can be replaced with robots. If you want to learn how to thrive in the fourth industrial revolution that is set to come, and some people are saying already here, you can actually download an ebook in our show notes called The Fourth Industrial Revolution, Preparing Your Firm to Thrive. Highly recommend it. Check it out. Back to the show.
And he said, that's a very tough question. And went away and discovered this thing called Netscape. I think it was, or Mosaic, the first web browser, and came back with the idea of operating our robot in the lab remotely using Mosaic. And so we got stuck into building internet controllable robots. And that was an amazing project. You know, it was used by over 500,000 people around the world over the few years we had it running. Eventually, of course, it got too expensive to maintain and keep it running, but it was a fascinating experience. And now, of course, everybody takes remote internet control for granted. Now, at about that time, my wife was working with Red Cross, and she tried to persuade me to build robots for clearing landmines. The landmines were then and still are a big problem in many countries, 70 or 80 countries around the world. And I said, oh, look, come on, that's much too difficult, much too hard. So undeterred, she got the chief of the armed forces to twist the other arm. And so at that stage, I had little option but to get stuck into it and realized that in contrast to robotics, there were lots of really simple engineering solutions waiting to be found. And so I had a fascinating time. I've spent quite a bit of time in Pakistan, where my wife's family come from, Cambodia, Bosnia, Lebanon, Egypt, many other mine-affected countries. And we made all kinds of different contributions. For example, finding ways to make protective equipment much more cheaply, and understanding how effective manual demining is, and even a bit of work on mine detection dogs.
We always hear the quote, it's all about the journey, not necessarily the destination. Well, I'm going to put a different spin on it here, but I wholeheartedly believe that. Here's my spin. James's journey got him to his destination with the knowledge, wisdom, and experience to really formulate this question and understand that. If you think about it, he went from sheep shearing robot. Obviously, he said he worked in aerospace and defense, worked on robotic controls, worked through the Red Cross because his wife twisted his arm and actually had a general twist his arm to work on mine detection, which led him to Pakistan, where his wife was from, where he stumbled upon this question. But it wasn't really stumbling upon it. It was because of the journey and, again, the knowledge and wisdom that he gained along the way that he was able to ask this question and then develop 15 to 17 years of research to now come up with this book that you can get in your hands on becoming an expert engineer. So again, the journey is so valuable. Don't be afraid to take on odd engineering jobs, because these jobs can truly help you along your journey and get you the wisdom, knowledge, understanding you need to excel as an engineer.
Now, as part of that, I found myself in Pakistan, and I started to realize that it was not the kind of place to work in that I had expected. I'd always been brought up with the idea that countries where people are paid very little per hour are very inexpensive places to get any kind of engineering done. You know, we always talk about manufacturing going to low labor cost countries. My experience was exactly the opposite. I was continually frustrated at the high costs of doing anything. It was a problem faced by every Pakistan engineering organization, and indeed every Indian engineering organization, and engineering in pretty much every developing country. It turns out to be a lot more expensive than you think, and even more expensive than in Australia. And that puzzled me, because I was employing engineers, and I knew that they couldn't do the kinds of things that I would take for granted in Australia, but I couldn't put my finger on what it was. You know, the best thing I could come up with was that they didn't have practical skills. But if you'd asked me what practical skills were at that time, I would have been stuck for an answer. And so as a researcher, I thought, this is an intriguing problem. What is it that these engineers are doing differently? They were not dumb. They were very smart young people, well educated in some of the best universities around the world. Pakistan, Indian-born engineers achieve amazing things in countries like America and Australia. How come they couldn't do similar things in their own countries? And this puzzled me. And so I started interviewing and watching engineers at work, thinking that I could collect data which I would be able to readily compare with all the data that other people would have collected about what engineers do around the world, only to find, and this was a gradual process of discovery, and a frustrating one at times, we found eventually that there was almost nothing on the detail of what it is that engineers actually do. Lots of people had studied engineers, but they'd studied engineers with quite different ideas in mind. For example, to learn how teams operate, or to understand how management operates, how organizations operate. And in all that research, no one had really bothered to ask what it was that the engineers were actually doing in terms of engineering. And so we ended up in this position of having collected data in India and Pakistan, but having nothing to compare it to. So then this problem attracted the interest of some really bright and wonderful students and some colleagues. So over the next, I guess now almost 15, 17 years, we've collected a massive data on what engineers do in Australia and in some other countries as well. And we can begin to answer. In fact, we've found good answers to these questions. And some really fascinating stuff has come out of this story.
So that journey was important because it allowed him to understand the questions he needed to ask. But I wanted to ask James, candidly, what he thought were the primary drivers that made engineering overseas much more expensive. Because as he alluded to earlier in the conversation, most of us think that offshoring work overseas is less expensive. So I wanted to ask James, what are the primary drivers and reasons why engineering can become so expensive overseas?
What I'm telling you now has only come out towards the end of the research. It took 15 or so years to really understand what was going on. And it's quite possible other people may come back at this problem and come up with quite different understandings. But let me tell you an interesting story. This was first-hand observation by one of my graduate students in India. He was watching as a gang of guys started digging up the road. And there was an engineer standing beside the road with a map folded in half. And he was directing the engineers because according to his map, there was a pipe under the road which was suspected of leaking and causing pressure drops in the surrounding water network. So at the end of the day, the engineer turned up. The gang of guys had dug this enormous hole, and there were a lot of angry residents because they hadn't been informed in advance that the road was going to be dug up. And the problem was that there was no pipe. And the engineer was scratching his head and told the guys, well, you might as well fill in the hole. And so I began to, this graduate student had a chat to some of the guys in their own language. And it turned out that these guys knew where the pipe was, but they couldn't tell the engineer, because for them to give the engineer the idea that they knew more than he did meant that their jobs would be on the line. They could easily find themselves without a job. You just don't do that. You compare that with what would happen in Australia, and I guess probably something similar in America. There wouldn't be a gang of guys with shovels. There'd be one or two guys with a digging machine. And the driver of the machine would say, here comes another ignorant engineer, only knows half the things he needs to know. And he'll say, mate, I know the pipe's not there because my mate buried it over there. And the engineer will say, oh, okay, so why don't you dig a small hole and prove it to me? So the fact that they can have that kind of conversation in Australia is something that is almost inconceivable in an environment like India and Pakistan, where you have an entirely different social system, where to question the wisdom of one's betters and seniors is to risk losing one's job. And there's no social welfare or negligible social welfare to help you if you do lose your job. No, that's not the only thing. There are many other factors. For example, languages. So the guy with the map speaks a mixture of English and Hindi, the national language. The guys on the shovels will speak a local dialect of a regional language. And the foreman who directs them will translate between the engineer and that local dialect. And of course, a lot gets lost in translation. And that adds up to uncertainty. So what you find is that workers in India and Pakistan, for example, if there's no supervision present to take the blame, they will sit there and do nothing. Because to do nothing actually is less risky than doing the wrong thing. So if there's any uncertainty, they will just simply stop. And so you get this almost universal observation that work stops without supervision. Now, in Australia, you would get someone like a foreman or a site supervisor, maybe even engineer, would be supervising something like 30 or 40 people on a site, maybe more. In India and Pakistan, you'd get an engineer supervising 2 or 3 people because it takes that much time and effort to help people who work and think in a different language understand exactly what's needed and to make sure that they do what's needed. So while the labor looks cheap at first sight, in terms of productivity, what that labor actually achieves and the indirect costs such as supervision and all the other support that you have to provide, that labor turns out to be very expensive. And that difference is masked by the implicit assumption that people make that labor in a place like India or Pakistan is cheap. Because people think that labor is cheap, they then jump into assumptions, for example, that it's not worth buying expensive tools. Consequently, the productivity is affected by the fact that they have low-quality tools. They often work with low-quality materials. And the result is high costs. And there's no better illustration of the high costs than the cost of safe drinking water. You know, to get safe drinking water in developing countries typically means you have to carry it. And the cost comes out to anywhere between $30 to $100 a ton. The lower end where women carry it maybe from a nearby well, and the upper end when you get it in plastic bottles, large plastic bottles. Here in Australia, in Perth, pretty much the driest corner of Australia, we get safe drinking water out of the tap at about $3 a ton. You get the same picture in energy. Energy, where it does something useful in a developing country, is typically 5 times as expensive as it is here in Australia. And people here complain about high electricity costs. And that's because of the, for example, intermittency of power. So in most developing countries, energy is intermittent. It's on for an hour or two and then off again, on again, off again. So you need standby generators. Equipment is poorly maintained. So the efficiency of the equipment is low. Quite often people have bought low-cost equipment in the first place, which has got a low intrinsic efficiency to begin with, and then it's poorly maintained. So that's why energy costs are extremely high, and you find these factors mounting one on top of the other, and so you end up in a situation where to achieve anything, it costs amazing amount of money, and very often considerably more than it does in a country like Australia, the US, or Europe.
That's very interesting because generally speaking, most people in organizations think by sending work overseas, they're going to be able to save a large amount of money. But you're really challenging that misconception, if I'm hearing you correctly.
Definitely.
So, James, what would be your definition of engineering? And more importantly, why do certain people and organizations struggle? You're alluding to a lot of the points that you discovered in India, Pakistan, and other parts of the world, but why do you think that is? Why do you think that there's such a struggle when it comes to engineering and actually making sure that projects are completed on time and on budget?
So let's look at the basics of engineering. Engineering is essentially the application of technical knowledge, some of which is scientific and some of which is learned by experience, and collaboration. Now, the principles of physics, for example, that water doesn't really travel uphill unless you pump it. Those principles apply equally in Perth in Australia, Peshawar in Pakistan, or Paris in France. They're the same everywhere. What is different, of course, is the way people collaborate. And without collaboration, you don't get anything done in engineering. That collaboration factor and the fact that it's different in different social contexts is something which engineers miss out on. Being brought up in a country like Australia, I took it for granted. For decades, engineering works. And it was only when I was confronted with the absence of good engineering that I began to be put in a position where I could start to understand these differences. Once we work backwards, we say, well, how does collaboration work in a country like Australia? The answer is it sort of works, and a lot of the time it doesn't work very well at all. And that's led us on to all kinds of fascinating discoveries. For example, we found that 2 global organizations involved in the oil and gas industry, organizations whose names you would instantly recognize. We investigated their design checking work and found that while they have extraordinarily detailed quality assurance systems to make sure that everything, every document, every drawing is thoroughly checked, not only by the originator, but also by engineers from other disciplines, the actual checking work is quite often skipped and not done. Engineers sign to indicate that they've done the checking, but actually they have not done the checking. And we found this over and over again in different contexts. Now, we've only done 2 formal studies, but we've got lots of anecdotal data to indicate that this is a universal problem. And then the question arises, well, why? Why is this such a consistent pattern? I'll tell you another one. So in maintenance, for example, any reasonable sized organization uses what's called a computer maintenance management system, or CMMS, which is essentially a sophisticated calendaring system that tells you to grease the bearings tomorrow or do whatever else. And we have found everybody reporting consistent issues with these systems. And in essence, it's how do you get the coordination, the effective coordination of people involved in maintenance? And it turns out to be incredibly difficult. And studies that have come out of Scandinavia indicate that maintenance and operations mistakes are typically costing companies as much as 50% of their turnover. Not 50% of their profits, but 50% of their turnover. And what it shows is that there's enormous scope for improving the way we collaborate in engineering. And essentially, that's what's come out in my book. What I discovered, along with my students and colleagues, was a systematic series of engineering processes by which engineers collaborate, but quite often without realizing what they're doing.
In my career, I've worked in the PLM space. So I've sold CAD/CAM, CAE, and PLM software tools to various different organizations in scope and size. And this is an issue across the board, as James is alluding to here and pointing out. There's oftentimes not documented policies, procedures, best practices that are happening. And it's even more prevalent today because a lot of the senior experts are retiring and taking their tribal knowledge with them, and they understand how to perform these procedures, whereas a kid coming fresh out of school, new employee at the organization, really doesn't have that firm understanding.
Let me give you an example. So the fundamental process that we first discovered is something we call technical coordination. And this seems to occupy about 30% of the time of engineers across all disciplines. Of course, there's variations from one day to the next, 1 week to the next, and maybe even between 2 engineers sitting side by side, but it's remarkably consistent. What is it? Okay, engineers need to get something done by somebody else, either because they don't know how to do it themselves, they haven't got time, or maybe they don't have access to specialized software or information that's needed. Now, in theory, an engineer could go up through the hierarchy. So I can ask my boss to ask this other guy's boss to ask that other person to look up some information and then send it back to me, and goes up the line and back down the line. Now, of course, you know and I know that if we do that, the message is going to get distorted. I'll get the wrong thing at the wrong time. So it's much quicker and more effective if I go across to Peter or to Jane and I say, Jane, do you think you could look this up? I know you've got really good access to all those specialized standards. Could you look it up, and so on and so forth? And look, if there's any problem, I'll get my boss to speak to your boss. And of course, Jane will just do it because we have a good working relationship. And she knows that I'll do something for her when she needs it. Now, it doesn't just happen. You know, I get students who tell me that they get really puzzled in the workforce. They get out there and, like one student said, look, I sent half a dozen emails to these people, and I finally went out on site and found that nobody had read the emails. They were doing entirely the wrong thing. And I turned around to him and I said, how many of your emails do you actually read? He said, I guess not all of them at all. But because students studying engineering, you know, they're not pointed at this issue of collaboration. They don't even know that it's there, and it takes them years to figure it out. You know, a really experienced engineer, when I explained to him this business about technical collaboration, he said, I realize I've been doing this for my whole life, but I just didn't notice it. And the really important thing is that you can never rely on formal authority. You've always got to persuade people, and they've got to be willing to do it because you want them to do it properly. They have to be conscientious about what they're doing for you, because otherwise it'd just be a waste of time. And they've got to want to do it in order for them to be doing it conscientiously. And so you've really got to gently persuade people to do it, and it takes up so much of your time. You're dead right.
That's a fascinating point that you bring up, James. It seems like there's a lot of common misconceptions just about engineering work in general. I mean, think about it. A lot of kids coming out of school that, prepared their entire lives to become engineers are frustrated when they step out of school and realize that a majority of the work is not actually sitting behind their desk crunching numbers and creating designs, but seems like what you're saying is it's a lot to do with collaboration and working together as a team, and making sure you understand how to get the right resources. So again, not sitting behind your desk crunching numbers. Is that correct? Also, this seems like an important topic you would cover in your book. Is that accurate?
It is. So I went to lots of engineers and I would approach them something like this. I'd say, listen, I want to talk to you. I want to ask you questions because I'm studying what engineers do. And so many of them would come back and say, but why are you asking me? Because I hardly ever do any engineering. I spend all my life doing administration. I'd say, right. Okay. So when you're doing the engineering, and I would hold up my hands to say, inverted commas, what is it that you're doing? And he'd say, oh, of course, calculations, design, that sort of stuff, the kind of things that we were taught in university. And I'd say, well, okay, so what's all the other stuff you have to do? He said, oh, meetings, contracts, checking, so much administration, paperwork. It's all, that non-technical bullshit. So I said, well, okay, so why couldn't you hire a clerical assistant to do all that for you? Oh, yeah, but you need to know the engineering in order to be able to do it. There's no point in checking a contract unless you understand the engineering issues behind it. Okay, so it is engineering work, all that other stuff. Yeah, but it's not real engineering, if you know what I mean. So here we have what in social science we call an identity issue. So engineers identify themselves with the technical work, and that's what they love to do, technical problem solving. There's nothing more exciting than solving a problem, trying to get somewhere where no one's been able to get before. And so many engineers get frustrated because all the other stuff they have to do gets in the way and interrupts them and takes them away from that technical work. And that instinctive feel that the other stuff is not engineering then means that, of course, it's just a blank space on the map. They haven't been given in their education a roadmap to understand what it's all about. So these formal and informal processes of collaboration is what we've discovered through our research. And that's what I've tried to write about in the book. So it's not just technical coordination. There's many others, and they're very complex processes.
So what advice or feedback would you give a kid coming fresh out of school who just obtained his engineering degree to avoid the frustration of not being able to innovate?
It is that engineering is really about collaboration, and collaboration can be mapped. It can be understood as a whole series of different processes. As far as I can tell, nobody has really written about these processes before in that sense. Lots of business schools talk about teamwork, and in fact, lots of engineering courses introduce students to teamwork, although they just assume that students will practice it without having to have it taught to them. But, studies of teamwork leave out the technical. They just focus on the social interaction between a bunch of workers and maybe a manager. When you introduce technical factors, as of course we live with every day in engineering, the collaboration has to go along different lines. So just for example, if you read the textbooks will tell you how to put a team together. They'll tell you about certain social tests that you can do, and you test the personality, and you get someone who's a leader, someone who's a good detail person, and so on and so forth. When you put an engineering team together, your first point of departure is, what discipline knowledge do we need? Do we need an electrical engineer on here? Do we need some electronics? Do we need someone who's an expert on bearings, for example? So that the technical coverage of engineers is the first starting point when you're building a team. And that's an issue which hasn't been explored at all by management schools because they don't understand the technical dimension. So that's why I think this book is really important, because it sets out for the first time, as far as I can tell, how engineers collaborate in an environment where technical knowledge is paramount. And in essence, at its simplest, what are engineers trying to do? Engineers are trying to make sure that the technical ideas behind an enterprise or a project are implemented sufficiently well so that the performance predictions they make to justify the project will come true. In other words, the client will end up with something approximating that what they set out to pay for. And it's so easy for that technical knowledge to be lost along the line. And so you get performance problems in the end because there was not enough understanding of the technical requirements by the people who were charged with putting it all together.
This concludes part 1 of our first episode of the Grinding Gears podcast with James Trevelyan. There's a lot of really good information contained in part 2. We just wanted to break it up into 2 different segments for the sake of time. Again, thanks for joining us for part 1. Part 2 is jam-packed with lots of useful information. Be sure to tune in.